Okay, so here's the last 10 problems, 41 through 50. So in triangle DAC shown below, EB is parallel to DC. If AC equals 28.5, what is the length of AB? Well, because these two lines are parallel, that tells us that these angles are the same. So this angle is congruent to this angle because they are corresponding. Same thing with this angle and this angle. And since they both all share this angle, that tells us that these are similar triangles. So AEB is similar to ADC. So if I want to know what AB is, I can set up a ratio using the fact that AC is 28.5, and I know that AD is 18 plus 4.8, which is 22.8. So I know this long length is 22.8 and this long length is 28.5. And then I know this short length is 18 and this is the length I want to find. So again, if they're similar triangles, I set up a ratio. So my ratio is going to be 18 over x, this side over this side, equals this long side over this long side. So 22.8 over 28.5. Cross multiply. 22.8x equals, multiply this way and we get 513. Divide by 22.8 on both sides and we get x equals 22.5 centimeters. 42 says Paula designed a three-dimensional scale model of a department store. The volume of the scale model was 25 cubic feet. So my volume is 25. The ratio of the model to the store is 1 to 20. So that means my scale factor is 20. Because it's volume, we have to cube my scale factor. So I'm going to multiply the 25 times my scale factor cubed. And when I do that, I get 200,000. And my units are feet cubed because it's volume cubed. 43 is what is the area of the hexagon? Well, it tells me in the part that is torn off, that I cut off because it was wrong, that each one of these sides, because this is my radius, each one of my sides is 8. And that's just a given thing, and it'll be given to you in the problem tomorrow. It says, what is the area of the hexagon? Our formula is apothem times perimeter of the base divided by 2. So my apothem is 6.928. The perimeter of my base is 8 times 6 because there's 6 sides. So times 48 divided by 2. And when I plug that into my calculator, I get 166.27 inches squared because it's area. Then it says, what is the area of the circle? Well, here's my radius. It's 8. The formula is pi r squared. So that's pi times 8 squared. And that equals 201.06 inches squared. And then it says how many square inches of paper will be left over as scraps. So I'd take my 201.06 because my circle is bigger. And I'd subtract the 166.27. And I'm left with 34.79 inches squared. That's what's left over. So then, suppose a dart is equally likely to hit any point on a board shaped like an equilateral triangle with a side of 30 inches. So it says, what is the area of the circle? Well, my formula for area of a circle is pi r squared. My radius is 5.8, so I get 5.8 squared times pi. So the radius of the area of my circle is 105.68 inches squared. The area of the triangle, I have to draw in my height. So this becomes 15 and this is 30. So to find my height, I have to do a squared plus b squared equals c squared. So a is 15 squared plus b I don't know because this is c, so plus b squared equals c squared, which is 30 squared. So 15 squared is 225 plus b squared equals 900 because that's what 30 squared is. So then I subtract 225 from both sides, and I get b squared is equal to 675. To find b, I have to take the square root of both sides. So b is equal to 25.98. So this height is 25.98. So now to find the area of a triangle, my formula is base times height divided by 2. Well, my base is right here, that's 30. My height I just solved for is 25.98. And then I divide that by 2. So the area of my triangle is 389.71, and that's inches squared. Then it says, what is the probability that the dart will hit inside of the shaded circle? So again, we're going to have shaded circle over the whole thing. Heart over whole. So my shaded circle is 105.68 over the whole triangle is 389.71. And when I put that into my calculator, I get 0.2711. And I can multiply that times 100 and get 27.1%. So either one of these answers will work. And the last two problems, the table below shows the number of diagonals that can be drawn in the listed convex polygons. So we have to find a pattern. Here we can see they're increasing by 1. Here this one's increasing by 2. This one increased by 3. 4, and this one increased by 5. So I think we're starting to see a pattern. So how many diagonals could be drawn for a 17-sided figure? So that means 17 goes here. So for 7 we've added 5, for 6 we've added 4. So for 17 we're going to have to add up to 15. Because when we get to 7 sides we've added 5. So we add 2 less than the number of sides. So we need to take this 14 and add 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 to it so that we get to 17 sides. And when we do that, we get 119 diagonals. So then it says, how many sides would a polygon have if it had 60 diagonals? So we want this column to equal 60. So we add 14 plus 6. I'm going to come back up here. And we get 20, plus 7 is 27, plus 8 is 35, plus 9, and I think I told you to change this to 65 because we don't hit 60. So plus 9 is 44, plus 10 is 54, plus 11 gives us our 65. So we end up with adding 11. So if we're adding 11, the number of sides is 2 more than that. So it would have 13 sides.